Hello everyone, welcome back to my YouTube channel. So in this video I am going to start a new concept, that is the trees in the data structure. Okay, so before starting to the trees, first of all let me just cover or revise the previous point which are needed to understand it further. Okay, so linear list. What is linear list? Linear list is a finite ordered collection of elements. So it means that the elements are to be arranged in a sequential order. Okay, so right here in the diagram you can see that the nodes I have shown nodes. Okay, so in the diagram you can see that each node except the first and the last one has both the predecessor and the successor. Okay, this is the successor for this node and this is the predecessor for this node. Okay, so it's kind of a linear structure. Okay, so in a linear list, each element except the first and the last has exactly one predecessor and the successor. That points I have already covered. Now come to the non-linear list, which is a part of the trees. So in a non-linear list, the relation is not a linear. Okay, it means like a tree-like structure, the relationship is one to many. Okay, the root node is the one and the childs are further grows from that root node only. Okay, so right here in the diagram this is the tree like structure. Here you can see that first node is the root node and the relationship is one to many. That means from one parent there are multiple number of nodes has been drawn, and each node has predecessor and the successor except the first root node, which do not have any kind of predecessor, and the child nodes or the leaf nodes. These are the leaf nodes, okay, which do not have any kind of successor. So where we actually use this tree data structure, the most common example you can take is the hierarchical representation. So in our PC, we come across multiple drives, C drive, CDE, and each drive further divided into multiple folders, and within the folder we have multiple number of files. Okay, so in that case the tree data structure has been used. So what is for these are the most commonly used terminologies which we need to understand first. Okay, so this is the basic video. So what is forest? Forest is nothing but a collection of trees, or we can consider them is as a acyclic graph. Okay, so right here you can see I have drawn the two diagrams A, B, C. So this is the root node and these are the child nodes. So right now there are some important results. What is that? A free node or a free tree with n nodes has exactly n minus 1 edges. So let me just elaborate it more. What are nodes? Nodes are these are the nodes and the edges. So what does it mean? Let us suppose we have n number of nodes, so the number of edges will be the less than 1 only. Okay, so right here in the diagram you can see 1 2 3 4. These are the 4 nodes and the edges are 1 2 3. Okay, so the number of edges are the less than 1. A forest of k trees containing a total of n nodes has exactly n minus k edges. So as I already told, a forest is nothing but a collection of trees. So we have given that a forest of k trees, that means a forest containing k trees has, and each node contains n number of nodes. Okay, so then we have to find out the number of edges. So the number of edges will going to be the n minus 1 only. So let us take how this has been derived. A forest containing k number of nodes, that is t1 t to the up to the tk. These are the number of trees, and each tree containing n number of nodes. Okay, so the t1 nodes contain n1 T1 tree contains n1 number of nodes. Likewise, tk tree will contain n number of nodes, and the summation of all these nodes will be the n only. Okay, and from the above result we have derived that the number of edges are the less than 1 the number of trees. So right here, for the tree T1 we have n1 edges, so the how many number of edges? Less than 1 only, so n minus 1 will be the number of edges for this first tree, and overall summation will be the e. So what I have did, I just add all of them, n1 n2 up to the nk. Okay, these are the number of nodes, and this minus 1 minus 1 minus 1, this will go up to the k. Okay, and this will going to be the e. So from that n1 n2 n3 we just n and this k, so we have found that the number of edges are nothing but n minus k. So I have taken one more example to just more clarify it. The question has how many edges are there in a forest of tea trees containing a total of n vertices. So the answer will be the n minus t. Okay. Now our next topic or the next terminology is the rooted tree. A tree is a recursive structure. So what does it mean, recursion? As we have seen in the, we can see that in the diagram, each node contain multiple childs. Okay, this a node has b c d, these are the childs, and further this node b contain two more childs. So this kind of, it's kind of recursive structure. Okay, each node has zero or more child. A node without any child node is called leaf node. Okay, and a node without a parent node is, okay. So what is written right here is the, what is leaf node? A leaf node is a node which do not have any further childs, and the root node is the one which do not have parent. Okay, so in this example these two are the same one because they have the same root, and rooted node means the root node which has the same root. Okay, right here we have just flip up the order b c d, and here c b d, still they are same. In case of unordered rooted trees this will be the same, and here the root node is the b, so this is not the same. The rooted tree is further divided into two, that is, one is the ordered and one is the unordered. Let us suppose if we take consideration the order, then those tree will be the different, as here you can see that the order is not even. But if we just consider them as a unordered rooted tree, then only these two will be the same. So right here, terminologies: what is child, what is parents, and what is siblings. So the parent is the one from which the further nodes are derived, and siblings are what? Childs of the same parent. So in this example right here, b c d are derived from a node only. Okay, so b c d are the siblings, a is the parent, and b c d are the childs of a only. Okay, right here, path. What is ancestors? From the root node to that node are excluding. Okay, ancestor, let us suppose I want to find out the ancestors of e. So we, from the root node, we have to take from the root node up to that node, excluding that node. Okay, so the ancestors of e, what will be? A, b, these are the ancestors. In case of j, let us take what will be the ancestors? A, b, e, these are the ancestors. What are descendants? Descendants means from that node, including up to the leaf node. Descendants means, let us suppose I want to find out the descendants of B, so we have to exclude this node and just all the below up to the leaf node will be considered as descendants. From the B, E, J, K will be the descendants nodes. For D, H, I, L. Now the most important concept is the what is the degree of a node. Okay, so degree of a node means the number of subtrees of a node. Degree, so right here you can see I have written the degree. Degree means how many number of childs a parent node contain. So A, you can see 3, so I have just written 3. For B, here you can see there is only one subtree, so I have written 1. For E, 2 nodes, then 2. The previous was the degree of a node, and right now we need to find out the degree of a tree. Okay, so there is a difference between degree of a tree and the degree of a node. So the maximum among all the nodes is going to be the degree of a tree. Okay, so how to find out the degree of a tree? Maximum among the degree of a all vertices. So in this example the maximum value is the 3, so hence 3 will be the degree of a tree. Next concept is the length of a path. Length of a path means the number of edges in a path. So how you can find? Length will be nothing but from D to L. So now let us take some more types of the trees. So first one is the binary tree. A binary tree is a finite set of nodes that is either empty. What does it mean? Let us suppose any node, that means there's nothing node. Okay, still it will be considered as a binary tree, or consist of a node called root node with two binary trees called the left subtree and the right subtree. Or we can say, what is binary tree? Having a root node and the two subtrees, and both of them need to be the binary also. Binary means, let us suppose this is the root node and these are the two child of this root node, then this also, that means this subtree also be a binary tree only. Okay, so next topic is the strict binary tree, or in other words it is also called as a proper binary tree. So in this case a strict binary tree is one which that each node has either degree 2 or the 0. Degree means the number of nodes a node contain. Okay, so right here in the diagram you can see that each node has a degree 2 or either 0. So the leaf node will contain degree 0 and the root or other intermediate node will contain 2. Our next one is the almost nearly complete binary tree. So the almost nearly or complete binary tree. So what does it mean? A binary tree in which all the levels except possibly the last level have the maximum number of nodes, and all the nodes in the last level appear as from left to right. Okay, so it means that all the nodes will need to have maximum number of nodes, but there is a exception to the last or child nodes. Either we have, or either the child node will contain maximum number of nodes or not, but the last level which need to be filled from left to right. So right here you can see that the last level is not filled completely, but they are filled in a, that means from left to the right one. So our next topic is the complete binary tree or the perfect binary tree. So in the perfect binary tree all the levels are filled completely filled. That means from top to the bottom all levels are completely filled. Now the degenerated binary tree. So a degenerated binary tree is a binary tree where every parent node has only one child node. Okay, so in this diagram, this is the left binary tree and this is the right binary tree. It simply means that each parent will contain only a single element, single node. The height of the degenerated binary tree is nothing but n minus 1. So the degenerated binary tree have maximum height and the minimum number of nodes.